Hello everyone, and welcome to our 11.3 Part 3 notes on area of regular polygons. So the first thing I want you to do is think back to what regular means. We have studied regular polygons before. We looked at the angles in regular polygons. Regular polygons had congruent sides. All of its sides were congruent to each other, as well as congruent angles. So all of the sides are congruent, all of the angles are congruent. And so we know like an equilateral triangle has 3 side lengths that are congruent and all of the angles are 60, so that's regular. And then a square is going to be a type of regular polygon because all of its sides are congruent and all of its angles are 90. And so if you keep going up, we have a regular pentagon, a regular hexagon, regular heptagon. So all of the sides are congruent, all of the angles are congruent. And here's my formula for a regular polygon. Now we're going to be looking at not the angles of a regular polygon, but finding the area of a regular polygon. And what you're going to do is you're going to say the area of a regular polygon, capital A stands for area. The area of a regular polygon is going to be equal to the apothem, lowercase a, times the perimeter divided by 2. So you're going to multiply your apothem and your perimeter times each other, and you're going to divide by 2. So the first thing I want us to do is think back to the different pieces of a regular polygon. And so when we looked at regular polygons, the first thing we did is we put a dot in the middle, and we said that these shapes were just made up of a bunch of different triangles. And so in a pentagon, you'd have 5 congruent triangles. In a hexagon, oh, that's not a good, there we go, much better. In a hexagon, you'd have the 6 congruent triangles. And the pieces that I just drew in, going from a center to a vertex, we're going to call that the radius. So the distance from the center of a polygon to a vertex, there would be 5 radii around a pentagon. There would be 6 of them in a hexagon. So 1, 2, 3, 4, 5, 6. And we know that all of those are congruent because this creates 6 congruent triangles. On the pentagon, you have 5 congruent triangles. So that is going to be the radius. So what is my apothem? That's a new word. Some people say apothem, some people say apothem. We laugh because even in our math department, people say it different. But I'm going to say apothem. And so what is the apothem? The apothem is going to be the height of any of these triangles. So like this would be an apothem. But it's going to be congruent. There's going to be 5 of those. So there's going to be one here. There's going to be one here. It is the distance from the center of the circle to any side length. And so that is going to be, you're going to look for that right angle every single time. It should be straight to that side length, and that is going to be the apothem. So it's the same all the way around. So in this hexagon, this will be the height of that triangle. Okay. So we're going to call that our apothem, the distance from the center of a polygon to any side. That's going to be the perpendicular distance. That's the shortest way to get from the center straight to that side length. Okay, and what is it going to do? It is going to cut the angle in half, and it's going to cut that side length in half. So we'll look at that a little bit more later. So it says, solve for the area of each regular polygon, round the answers to the nearest tenth if necessary. Okay, so all of these are regular. So the first thing I want you to note is that because these are regular polygons, that is why I'm able to use this formula. Okay, so let's use our area formula. Capital A for area is going to be equal to the apothem times the perimeter divided by 2. And I'm just going to use this just like a checklist. So I'm going to highlight my apothem in pink. There's my apothem. Let's go ahead and do that for all of our problems. There's the 7.2 from the center to the side. And so there is my apothem. I've got that part. I'm going to do a check mark. I've got that part. So that's going to be 10 times, we want to multiply that by our perimeter. Well, what is the perimeter? The perimeter is going to be all the way around the outside of this regular pentagon. So if this is 14.5, then all of these are 14.5 all the way around. So how would you find the perimeter of that shape? Well, you would do, the perimeter is going to be equal to 14.5 times 5. It's kind of like saying it's the base of that triangle, all of those added together. So 14.5 times 5 is going to give me a perimeter of 72.5. So now we have our perimeter. I'm going to highlight that in yellow. That's going to be 72.5 is the distance all the way around the outside of that shape. And so that was my perimeter. I've got both of those pieces, and so my area is going to be equal to 10 times 72.5 divided by 2. So I'm going to multiply that by 10, so 725 divided by 2 is going to give me an area of 362.5. There's not units there, so I'm going to write units squared so that we know that area is always in units squared. So whatever they measured, and 14.5 doesn't have a unit next to it. So whatever that measurement is going to be units squared. 362.5 is how much space is in the area of this regular pentagon. That's what you're finding. So let's do that again. Area equals lowercase a, apothem, times p, divided by 2. So what is my apothem in this picture? 7.2, so area is going to be equal to 7.2, times my perimeter. Well, what is my perimeter? My perimeter is not 6.9. That would be just finding the area of this triangle if I were to draw it in. It's not just 6.9. How many of those 6.9s do I have? Well, what shape is this? We have a 1, 2, 3, 4, 5, 6, 7-sided figure. So my perimeter is going to be equal to 6.9 times 7. So when you do 6.9 times 7, that's a heptagon. That's going to give me a perimeter of 48.3. So there's my perimeter. All the way around the outside of this shape. Since it's regular, all of those sides are the same. So 7.2 times 48.3, and we're going to divide that by 2. So when you type that in, you're going to be using your calculator a lot today. We've got 1, 2, 3, 4, 5, 6, 7. Make sure I type that in right. 6.9 times 7 is 48.3 times my apothem of 7.2 divided by 2 is going to give me, I'm going to round it because it's 173.88. They tell me to round the answers to the nearest tenth if necessary. So that's going to be 173.9 approximately units squared of area. So that does round up. Okay, so that's how much space is in that regular polygon. So this polygon is actually a little bit smaller than our previous problem. All right, let's do this one more time. Area equals A times P divided by 2. What is my apothem? My apothem is 10.4. What is my perimeter? Well, my perimeter is going to be all the way around the outside of this shape. That is a 6-sided figure, so perimeter is going to be 12 times 6. So we're going to have area equals 10.4 is my apothem times my perimeter. My perimeter is going to be 12 times 6, which of course is 72. And then we're going to divide that by 2. So there's my apothem. Here's my perimeter all the way around the outside. So that 10.4 times 72 divided by 2 is going to give me an area of 374.4 exactly. So this is not rounded, this is exact. That is going to be units squared. So there's my area of that last one. So on your assignment, there are going to be 6 problems just like that, where you're given an apothem and you are given a side length. So the most complicated part of it is that you have to find the perimeter, and then you just plug that into your formula. What makes this a little bit harder is sometimes you're not given the apothem and sometimes you're not given the side length. So sometimes we're going to have to solve for the apothem or the side length. So here's a few helpful hints. You're going to draw on the triangle, so draw on the radius and draw on the apothem, and you're going to create a right triangle. We're going to solve for the top angle by doing 360 divided by 2n in that right triangle. And then use either trig or special right triangles to, it says use either trig to solve for. Use either trig or 40, let's say or 45, 45, 90 if it's a 45, 45, 90, or 30, 60, 90. If it's a special right triangle, you can use those shortcuts, but you can always use trig. Okay, so it says solve for the area of each regular polygon, round the answers to the nearest tenth if necessary. We are only, just to save time, going to do 1, 2, 3, and 6. 4 and 5 we'll come back to tomorrow and look at those. Those are a little bit more challenging. So just to get this process started, we're going to start with what's normal. Okay, so what is given? A side length is given. So I'm going to put that. I usually like to work with the triangle that's on the bottom. So I'm going to draw on a radius here, from here to the vertex, from here to the vertex. Y'all are used to working with triangles that have the base and then the height straight up and down, and so that we're going to help ourselves out. Since this is a multi-step thing, we're going to typically, since they're all the same, we're going to go ahead and just, most of the time, we'll just go ahead and just draw this into the bottom. So there's my apothem. I do not have my apothem. It's not given. But what is my side length that is given? It says the side length is 6 centimeters. So I'm going to go ahead and write that down here, 6 centimeters. So what is that? We want to work with this right triangle. Now, these are congruent right triangles. This yellow one is going to be congruent to this blue one. Okay, so I don't care which one you work with. I'm typically going to work with the yellow one just because I'm a creature of habit. So what is that apothem in pink due to that side length? Well, it's going to connect to the midpoint, so it's going to cut it in half to 3 centimeters here and 3 centimeters here for my short leg. And so right now, I can't use Pythagorean theorem because I only know 1 out of the 3 pieces of this right triangle. But if I can find an angle, then I can either use trig or special rules. And so what is the distance all the way, or not the distance, but how many degrees go all the way around this center point? We know that that is going to be 360. So how many sides do I have in this shape? I have 6. So what is 360 divided by 6? That is going to give me a 60-degree angle from here to here, okay? If that whole thing is 60, what happens to that apothem? Well, the apothem is going to divide it by 2. So what does that give me? That gives me a 30-degree angle, both here and here. Why is that important? Because that creates a 30, 60, 90 triangle. This is a 30-degree angle, this is my 60-degree angle, and then of course there's my 90-degree angle. And so we can use our rules for special right triangles. When you have area equals A times P divided by 2, well, what is it really easy to find? My perimeter is really easy to find because this whole thing was 6, so my perimeter is going to be equal to 6 times 6. Well, what is 6 times 6? That's going to give me 36. So I've got my perimeter. The only thing I need to find is my apothem. So how in a 30, 60, 90 triangle do you go from the short leg, which is 3, to the long leg? We're going to multiply by root 3. So you're going to multiply that by root 3. And what does that give me? My apothem is going to be equal to 3 times the square root of 3. So my apothem is 3 root 3. Check that off. My perimeter is 36. We're going to multiply those together, and then we're going to divide those by 2. So at this point, everybody in the room will pick up their calculator when we're in class, and we're going to type in 3 root 3. So 3 root 3. 3 root 3, even if you had done it with trig, if we had done tangent and done tangent of 30 equals 3 over a, we still would have gotten 5.19615, blah, 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 blah. When you type in 3 root 3, you get 5.19615, but we're not going to round into the very, very end. So that's exactly what my apothem is. 3 root 3 is 5.196, and it keeps going. We're then going to multiply that by 36. That gives me 187.061 and keeps going. Then we divide that by 2, and we round at the very, very end. We want these answers to be not rounded into the very last step. So what is this about? This is about 93.5 centimeters squared, since it gave me my units right here, of area in this regular polygon. Okay, let's do number 2. Number 2 is a triangle. So if we knew the base and height of this triangle, we'd just go base times height divided by 2, but we do not. All we know in this picture is that we have a radius that is of length 2. So this is going to be 2. This hypotenuse is going to be 2. I draw in my apothem. It's right here. Okay? And so there's our meters. And so what do we need to do? We need to find this angle right here. So remember, we're going to do 360 divided by 3. 360 divided by 3 gives me 120. And then what does that apothem do to that 120? Because 120 only goes from here to here is 120. If that's 120, when you divide that by 2 with the apothem, that is going to give me a 60-degree angle. So why is that significant? Because that is going to create two 30, 60, 90 triangles that are congruent. And I'm going to work with the one that's on the right, again, just because I'm a creature of habit. Okay? So we know that our hypotenuse on this one, our hypotenuse is 2. So how do you go from the hypotenuse in a 30, 60, 90 triangle to the short leg? You're going to divide by 2. Okay? You're going to divide by 2. To go from the hypotenuse to the short leg, you're going to divide by 2. So my apothem is going to be equal to 1. If my short leg is 1, how do you go to the long leg? Because we also need to get our x right here, because it's going to help me with my side length. We're going to multiply by root 3. Multiply by root 3. So x is going to be equal to 1 root 3. Okay? And so as far as finding the area of this shape, area is going to be equal to my apothem, which I just found. My apothem is 1. My hypotenuse is 2. So a times p divided by 2 is going to be equal to 1 times my perimeter. Well, what is my perimeter going to be? Now, this is where it gets a little bit tricky. My perimeter is going to be this side length, which is 1 root 3. So type that into your calculator, 1 root 3. That needs to be doubled because there's 2 of those. So I'm going to take 1 root 3. I'm going to multiply that by 2. And then how many of those do I have in this shape for the perimeter? All the way around the outside is going to be 3 of those. So I'm not actually going to write it out. I'm just going to write 1 times... Let's see, 1 times perimeter divided by 2. 1 times the perimeter divided by 2. So the perimeter is going to be in my calculator. Okay, so what do we do to get our perimeter again? Just remind me. That was going to be 1 root 3 was half of my side length. So 1 times the square root of 3, 1.73, and it keeps going. We multiply that by 2 to get the side length. And we take that number and multiply that by 3 to get my perimeter. My perimeter is about, let's say, let's just do this. My perimeter is equal to 10.39, and it keeps going, okay? So I'm going to take that number that's in my calculator, I'm going to multiply that by 1, and then I'm going to divide by 2. What does that give me for the area of this shape rounded at the very, very end? This is going to round to about 5.2 meters squared of area. 5.2 meters squared. So you're doing a lot of this work in your calculator. All right, this one, let's see, area equals A times P divided by P. Let's see what's easiest to find. This is going to be really, really easy to find my perimeter because this is a 5-sided figure. It's a regular pentagon. And so if I have, for my perimeter, I'm going to do perimeter is equal to 8 times 5. What does 8 times 5 give me? That gives me a perimeter of 40. Okay, so now we have our perimeter checked off. We just need to find our apothem. So let's go ahead and draw that in. We need our apothem. So my area is going to be my apothem times the perimeter divided by 2. So let's draw in let's draw in the radius. From here to here creates the triangle. Here's another triangle, or here's another radius that creates the triangle. The apothem is going to be the height of that triangle. What does it do to that side length of 8? It is going to cut it into a 4 miles and 4 miles here. Okay, so how do I find this angle? I'm going to do 360 divided by 5. 360 divided by 5, I believe, gives me 72. Let's try that again. 360 divided by 5. That's going to give me 72. And so if that is 72, what is 72? Then that apothem cuts it in half. So what is 72 divided by 2? That is going to give me 36 degrees. So this is not a special right triangle problem, and so I'm going to have to use trig here. So what am I going to do? I'm going to type in, this is the opposite, this is the adjacent. So let's go ahead and label that. From the 36-degree angle, this piece is opposite, this piece is adjacent. And so that is going to be tangent. So to find my apothem, it's going to be the tangent of 36 degrees is equal to opposite over adjacent. Again, we put this over 1 and cross multiply. So our apothem is going to be equal to 4 divided by the tangent of 36. So we're just going to type that into our calculator. We're not going to round it. 4 divided by the tangent of 36. That's going to give me 5.5055, and it keeps going. We're going to multiply that by 40, and then we're going to divide that by 2. That gives me an area rounded of about 110.1 miles squared. So that is the rounded area of this shape. Okay, we're going to skip 4 and 5 just for purposes of time's sake, and we're going to do number 6. Now, number 6 is easier than it seems because it gives you a perimeter all the way around the outside. It says is 32. So we actually already have of our area equals A times P divided by 2. They already give you your perimeter. Area is going to be equal to whatever the A is times 32. We found our perimeter, 32, divided by 2. So now we just need to go get our apothem to multiply that by. So what we can do, we know that if the perimeter is 32, this is a square, so divided by 4 gives me 8. So this side length is 8 from here to here. And then this side length is also 8. All of them are 8. So what is 8 times 8? What should our answer be? Our answer should be equal to 64 meters squared. But let's use the regular polygon formula to see if it's the same. Okay, so we would do this in the easiest way we can, which is just to go 8 times 8 is a square of area of 64 meters squared. But let's do this with the just for a little bit more practice. So we draw in a radius to the vertex, draw in a radius to the vertex. That creates our triangle. What is the height of that triangle? It's going to be the apothem. It cuts that 8 into a piece that is 4 on this side, 4 meters here, and 4 meters here. Okay. How do I find this angle? I'm going to do 360 divided by 4 gives me 90. So that from here to here is 90. So what does the apothem do to that? It divides it by 2. And that makes this a 45, 45, 90 triangle. So both of these are congruent 45, 45, 90 triangles. So I'm going to work with this one on the right. Again, those are congruent, so it does not matter which one you work with. If this has a leg in a 45, 45, 90 triangle, this leg, 4, should be congruent to this leg. So what is our apothem going to be equal to? Our apothem is going to be equal to 4. So this one seems more complicated than it is. Our apothem is 4. We don't need to find our radius. So we're just going to do 4 times 32. And I'm going to divide that by 2, which does, in fact, give me an area of 64 meters squared. So this actually works as well because it's a regular shape. You can use base times height since it's a square, or you can do A times P divided by 2. No formula that we have given you has contradicted a different shape, okay? And so 4 and 5, we'll start with those in class on Tuesday. And so your assignment is on the back. As far as the assignment goes, I just want to make a note. On the assignment, we are for sure doing the first 6, so just in case you were learning from home today, let me pull this up real quick. We are for sure doing the first 6. So let me go back. Let me go to this one. Okay, yes, we are for sure doing the first 6, 1, 2, 3, 4, 5, and 6. I want you to do 8, 10, and 12. That's like the ones we just did. And then put a star on 7, 9, and 11. You could attempt those if you would like to. Those would be bonus style questions if we had those on our test, but that's something we're going to continue to work on. And so if you want to try those just to see how you do, we can check those in class. So you're doing 1 through 6, and then 8, 10, and 12. So a total of 9 problems. In case you were learning from home today, on the back, that is what we are editing in class.